Hi, everyone. Thank you for joining today's virtual training on Benchling Insights. My name is Ankita Goswami, and I'm part of the product marketing team at Benchling, focused on the Benchling Insights product. I will also be the moderator for today's training. Today, we are thrilled to share the recently launched Benchling Insights product with you. With Benchling Insights, all of you, our customers, now have a powerful solution to query, visualize, and collaborate on the data you've been collecting on Benchling, all seamlessly within the product. We hope that with Benchling Insights, you now have the tools to make faster, more informed decisions about your scientific pipeline and operational processes. Before we begin, I'd like to introduce today's speakers, Sanjay Saraf and Brandon Kirk. Sanjay is a product manager at Benchling focused on the Benchling Insights and warehouse products. Before Benchling, Sanjay led healthcare and biology partnerships at Palantir Technologies. He received a degree in biomechanical engineering from Stanford University and has conducted research in cellular biomechanics and small molecule biophysics. Brandon is an implementation consultant at Benchling, focused on rolling out the Benchling platform to companies across the globe. Before joining Benchling, Brandon held various positions in the strain engineering space and received a degree in biochemistry and molecular biology from the University of California, Santa Barbara. Today, we will start out with a brief product overview, followed by a product demonstration that will cover 3 unique user stories. These user stories are meant to showcase the various applications of the Insights dashboards and their business impact. Next, we'll go through a step-by-step demonstration of the Insights application, showing you how to build a dashboard and set permissions yourself. And then we'll end with a Q&A session. So please feel free to submit questions at any time by clicking the Q&A button at the bottom of the screen, and we'll be sure to try to get it to as many questions as we can at the end of the session. With that, I'll pass it along to Sanjay to take us through the product introduction.
Great, thanks, Ankita. So I want to provide a little bit of framing for the problem space that Benchling is trying to solve. We're seeing a big shift in biopharma from traditional pharmaceutical drugs that are chemical-based to biologically based drugs. And that change doesn't just mean an increasing complexity from a molecular perspective, but an increasing complexity from a process and data perspective. So what we see as sort of the downstream sequelae from that change is complexities in data collection. Data is now scattered across multiple tools, instruments, and databases, and that results in 2 problems. The first problem is when trying to answer questions, I have to bring a bunch of data together. And the second is that the data model that I'm using will change from place to place. Ultimately, that means that analysis, if it happens at all, is disjointed, and often it doesn't happen. So Benchling as a platform has been a leader in creating a unified data platform for data capture. Experimental data generated from teams or from instruments or from automation is brought into the platform and is brought into a cohesive, unified data model. That data model is now able to be analyzed using the Benchling Insights product. So what capabilities are we now supporting with this new product? The first is that I'm able to analyze all of the structured data in the Benchling platform directly inside the product. So now I can open up an Insights dashboard and answer questions that I couldn't have answered before. Those dashboards and reports provide a full view of your R&D. That means that I can answer a bunch of classes of questions that I couldn't answer before, including scientific, operational, and administrative ones. Third, I can actually do calculations, things that I might want to do for my science, or derive specific metrics that are useful for my organization. And then lastly, I can bring those dashboards to other people and share them easily so that other people in my organization can answer the same questions that I have.
Great. Thanks for the product introduction, Sanjay. So I'll take over from here and go over some of the use cases that our customers might be using the Insights tool for. So at Benchling, we like to think of our insights in 3 different flavors. So there can be scientific insights, operational insights, and administrative insights. Scientific insights are related to the biologics that companies are creating and the assay results that are tied to them. So in this case, it might be a single experiment and you want to compare entities within that experiment, or you might also want to do cross-experimental results that were performed by different researchers or at different points in time. Operational insights are related to things involving the process and workflow efficiencies at a company. So for example, identifying bottlenecks in your research workflow or diving deeper into the resource allocations of your company. Lastly, the administrative insights help with day-to-day management of your Benchling platform. So for example, making sure that researchers are compliant with their notebook submission and review process. So today we'll be introducing an Insights webinar organization and going through some customer vignettes of researchers and day-to-day activities that they might be using the Insights application for. So in this Insights webinar organization, the organization is a strain engineering company that is tasked with using microbes to produce high-value chemicals from an eco-friendly feedstock. So in Vignette 1, we'll be focusing on the notebook and molecular biology applications. And what we want to find out is how are my researchers submitting their entries for review and who needs to submit. Vignette 2 will focus on the registry and inventory and sample tracking module as a whole. And we'll focus on a scientific dashboard to compare experimental results across experiments that were performed on different strains over different periods of time. Lastly, Vignette 3 will encompass the entire Benchling platform end-to-end, and we'll focus on how a program manager or R&D director would be able to allocate resources and identify bottlenecks in their research workflow. So let's introduce Vignette 1. Vignette 1 is focused on the notebook usage and policy compliance. In this situation, our Insights webinar organization has a platform for the production of short-chain fatty acids. They've identified a strain that they think is a good candidate to move forward to large-scale fermentation to produce large amounts of their product. Per company policy, however, it is essential that all notebook entries within a particular project get reviewed before the next step of the workflow can be moved on to. So in this case, a researcher might want a dashboard that's created to quickly identify the notebook entries that either need to be submitted for review or still need to be audited. To demonstrate this, I'm going to go into the Benchling platform and show you what a day-to-day workflow might look like using Insights. So I can see here I have many projects at my high level, and I have a project for my short-chain fatty acid platform. If I click into the project, I can see that there's many notebook entries created by several of the users within the Benchling organization, but it's hard for me to identify which ones need review, especially if there's many researchers that have outstanding notebook entries. In order to better get an overall look of these notebook entries, I'm going to go to the Insights application and then go to my notebook management dashboard. When I click into the dashboard, I can see that I'm given a few default views. For example, a user-by-user representation of whose notebook entries have been created and where they are in the process of submission. I also have a count of all the notebook entries within each project. So I can see maybe which projects have the most kind of ongoing work going on within them. I can also see down here that I have a section for in progress and needs review entries to be listed out. And what I'll see is at the top, I have a parameter called project. Parameters can be used to filter queries and change the view of a dashboard. So in this case, I want to know the entries in the short chain fatty acid project that are either in progress and need review so that I can identify the researchers who need to go about that process. So if I click into the project value, I can see that there's a drop down and I can choose the short chain fatty acid platform. When I do this, these bottom two blocks are populated with the notebook entries that either are in progress, so need to be submitted, and who the author is. I can also see the same things for entries that need review and who the auditor is that needs to click accept on the notebook entry. So this is a quick way to identify all of the notebook entries that need to be sort of validated before a process can move on to the next stage. And so the business impact of this is that the company is able to rapidly progress to the next phase of the workflow without delaying due to compliance issues. The next vignette is focused on cross-experimental insights. So in this case, the R&D team on the Vanillin platform has completed the characterization of many, many strains and wants to identify the top performers that they think are good candidates to move on to the next stage. In order to do this, they need to take the results that have been captured across many months and many high throughput screens and aggregate that data together so they can get a big picture view of the actual leaders in that pipeline. So the solution here is to leverage the insights to do a query which joins all the results captured on the vanillin producing strains. So again, I'm going to go back to the Benchling application to demonstrate the use of this type of dashboard. So if I go back to my projects and I go up to the top view of projects, I'm now going to go into the Vanillin platform. I can see here that there's many entries related to some scale-up fermentations, but there's also the strain evaluation data here. So if I'm a researcher and I'm evaluating a new strain, what I might be doing is using a notebook template to sort of organize my work. Notebook templates are a good way to standardize your workflows. So in this case, a transformation of electrocompetent cells can be standardized with tasks on day 1 and day 2. As a researcher, I can also use a registration table to tie the strains that I'm creating and push them into Benchling's registry. If you'd like to learn more about things like registration tables and how to efficiently use your registry, I recommend that you also attend a sample tracking seminar that we're hosting next week. So as this researcher, I've just registered a new strain that produces vanillin, strain 33. And the next thing I want to do is associate some results with that strain. To do this, I'm going to use Benchling's run application. Benchling's runs can be used to integrate lab instruments with the data and integrate them with Benchling's results module. So what I'm going to do is choose a file that I created several weeks ago, but may have come off of an HPLC machine, and press insert. After I've inserted the run, I can see that the results that have been captured, both of the vanillin titer and the consumption of the feedstock, have been captured against strain 33. But when I'm looking at just this, this sort of assay right here, I'm only seeing one strain, and I'm not getting a big picture of what this means in the context of the rest of the research that's been done leading up to this. So in order to do that, I'm again going to leverage the Benchling Insights application, and I'm going to use the high throughput screening data for the Vanillin platform. So now that I'm in here, I can see that there's several blocks on this dashboard that I can use to visualize the data. So one being a time course, where I can filter between several strains to be viewed on the time course of vanillin production over time. I can also see that there's a quick dashboard of the final time points of vanillin concentration and the final time point of the feedstock. So right now I see that the 3 strains have already been configured into the view, but I want to see how strain 33, which I just tested, compares to those strains. So if I type in strain 33 here and hit save, I can actually see that strain 33 is populated onto this dashboard. And I can in fact see that the final vanillin titer for this strain is higher substantially than the rest of the strains that have been tested here. And on my final time points, that includes all of the strains in the program, I can see that strain 33 is indeed the highest. So in doing so, a researcher was quickly able to test the actual importance of their results that they had just captured in real time. So the business impact of this is that a researcher is able to gain rapid insight into cross-experimental results, as well as improve their collaboration with other scientists. So instead of having to kind of aggregate data together manually or have a meeting to compare data, all that data is available in the Insights application. The last vignette is focused around a situation where an R&D director is tasked with identifying where resources are going within the entire organization, as well as identifying bottlenecks that are causing delays in the company's research pipeline. So in this case, the solution is to leverage Benchling Insights to use both the requests module and results module to understand where resources are going and where processes are getting stuck. So to demonstrate this dashboard, I'm going to navigate to the requests module, which is Benchling's system for intaking a request to perform specific assays or processes on biological entities. So in this case, I can see that our organization has a request for an 100-liter scale-up that was created 3 days ago. When I click in, I can see that the requester has mentioned some metadata about what they want the actual scale-up to be, and mentioned the strain in the samples bar right here, that this is the strain that they want to scale up. As an executor of the request, I can hit execute and choose to execute the request from a notebook template. So I have several options, but I will choose to execute from a notebook template. And I'll choose the template for an 100-liter fermentation and give it a descriptive name. When I execute the request from a template, I can see that the input samples are immediately brought into the template. Using a template also standardizes the way that these 100-liter scale-ups are done. So I can see that there's a place for the run plan, reaction conditions, as well as a place to capture the final results. This results table here can very easily bring in the samples from above. So I can see that it's recognizing the input sample of the request. And I can bring in strain 22 and then capture a start time for this fermentation. But as an R&D director, I want to know how long it's going to be before I can see this final concentration result and then have that data be actually submitted and reviewed. So to actually see a good estimate or a dashboard that displays sort of how long each process is taking, I can use the Insights tool here. And then go to the program management dashboard. So in this dashboard, first what I'm looking at is the resource allocations by platform. What you can see here is it's giving an estimate spend based on the amount of results being generated by each platform, giving an estimated spend of how much that platform is taking up in various sort of points in the research workflow. So you can see here the Vanillin platform is spending about $20,000 over the course of the organization's lifetime on 100-liter scale-ups. Secondly, I can see a dashboard for turnaround time by process. And this is defined by the amount of time on average that it takes from the point of a request being created to the results being submitted in days, how long that's taking for the company. So here I can see that if I was wondering how long it would take for me to get those 100-liter results, I can expect that it's going to be about 7 days before those results are submitted. So again, Benchling Insights was leveraged to create quick visualizations to identify broad views of your organization's research pipeline. So lastly, the business impact of this is that R&D directors can maintain an up-to-date pulse on the business and make rapid trade-off decisions and prepare for leadership discussions with information about things like cost per department. Great. So I hope that demonstration gave you all an idea of what the possibilities are in terms of variety of use cases for insights to be valuable for. But the next part of the meeting today is going to be surrounding an actual configuration training so that you as researchers and leaders in your companies can feel comfortable configuring a dashboard that's valuable to your organization. So for the agenda, I'll go through how to create a dashboard and set the permissions on who can access and edit the dashboard. We'll go through how to write queries to power your dashboard. We'll go through how to add multiple blocks, as you saw previously, as well as create the parameters that we were using to filter our visualizations. And then we'll go through how to manipulate the visualizations of your data. So in this case, we'll be creating a dashboard and then configuring a line chart to view the actual output of the data. Great. Okay. So when you are configuring a dashboard, it's very similar to the way that you would create things like projects or other registry schemas in Benchling. You're going to use this blue plus icon to configure a new dashboard. When I click the plus icon, I'm popped up with a modal, and I have three things to decide on. The first is the name of my dashboard, which today we'll be focusing on a use case where we're testing the toxicity of different toxins on the growth curve of the strains that are at my company. Next, we'll pick a project. The project is extremely important because these are where the permissions are defined. So in terms of the user having read, write, or none access, this is all defined at the project level. So whatever project I put my dashboard into, the user will have the same access to that dashboard as they have to the project that that dashboard lives in. And I'll try to reiterate that a few times as I go about this configuration. The next thing that I can do is add a description to my dashboard so that people looking at it get a more detailed idea of what this dashboard is meant for. I can create my dashboard. Great. So when you create a new dashboard, you're immediately populated or navigated to block 1 of the dashboard. So just to give you guys a step back in terms of what we were looking at previously in the demonstration and what we're looking at now here in the configuration, the view that we were looking at in the demonstration was the dashboard level view, where we had several blocks. So some of them had 2 or 3 blocks. Some of them had as many as 4. So in this case, we're configuring a dashboard, and we have been navigated to the first block of that dashboard. To go back into editing the dashboard, I can use this pencil, and that will take me back to the view that I was in when I first created the dashboard. So this is the actual view that's used to configure and edit your blocks of your dashboard and write the queries that power the actual the data. So there's 3 sections. The first is the coding block, or the block where you can write your query. The second is the schema browser, where you have access to all of your structured tables that are within Benchling. And the last is the output block, which is where the output of your query is populated. So the first block I want to talk about is the schema browser. These are all of the structured tables that live within Benchling. So these include all of your registry items, all of your results tables, everything related to your inventory, requests, as well as notebook entries and a lot of other things. It can be a bit overwhelming to scroll through these and all at once. So I do want to direct you to the resource docs.benchling.com, which we will follow up with in an email as well. It's a good resource that gives you a graphical visualization of how all of these tables connect together. But for now, it's useful just to scroll to my strain table, or maybe I'll use the search. And I'll search for my strains. So what I can do when I find my strain registry table is click into it and get a 5-row preview of all of the information that's in that table. So these are all of the columns that are in the table. So for example, the first column is Benchling's specific ID. There's also a source ID that gives information about where that entity lives within Benchling. I can see there's a lot of other information here, like date create or created at, modified at. But if I want to see sort of the metadata that my researchers have put in, I can scroll to the right and see that there's information for what plasmid the strain harbors, the species, the parent strain, resistance, and genetic background. So I can see here that this table contains a lot of columns. And maybe as a quick view, I'm not necessarily interested in seeing all of the columns. So I want to create a quick dashboard that simply lists the important strains and the metadata from those strains. So what I'll do here is copy this table to my clipboard so that I can paste it in my query that I'm about to write. And then I'll do a quick query to actually select a subset of the columns from the strain table. So in this case, I'm interested in the name, when the strain was created, the genetic background, the resistance, and the Benchling ID. And I want to grab those columns from my strain table. And what I can do then is hit run query. And you can see here my output table is actually the list of all my strains with the specific columns that I've decided to select from there. So a couple things to point out here, one being the ID column. So you can see here that the ID column is the Benchling specific ID, but when it's outputted in my table, it's outputted as a chip. This chip is actually clickable. So if I click here to strain 33, which is the one that we discussed earlier, I can actually see all the metadata and see all the results that have been captured against it. So this is a useful way for if you're writing queries to return you interesting things that you want to go look deeper into. The chips are a good way to be able to quickly navigate out of insights and into either the registry or the inventory. But if you're interested in seeing the raw view, you can always use this button to show the raw output. So now I'm given the actual Benchling specific IDs. At any point, you can download your output as a CSV. This will output the raw output as your CSV. I can also expand any of these sort of sections so that I can get a larger view of what I'm looking at. So again, here's my list of all strains. What I also want to do is name my block. So to name a block, I can simply use the pencil right here and name this block as list strains. And then we'll be set with our block. So the next thing that we want to do is create a new block. So if I'm here, I've created my list strains block, but I can see that I can very easily use this icon here to add a new block. Great. So in this block, what we're going to do is create a more sort of interactive dashboard that relates to the strains as well as a toxin that they've been treated with and how that affects the actual growth of the strains on a Petri plate. So we're going to call this one toxin kill curve. And what we're going to do here is actually join the data from our strain table as well as a result table that lives in this organization that's called toxin kill curve. So we'll actually join two tables together. And then what we're going to do is visualize the actual decrease in growth over increasing doses of several toxins. So the first thing that I want to do is scroll to my toxin kill curve table. And I can see I can find it right here. An important note right here is that there's both a toxin kill curve table, but also a table that's appended with a $ and raw. These tables exist for both for several things within Benchling, but the important thing to note is that for results tables, these raw tables contain all results regardless of whether or not the entry that they live in has been accepted. And for registry items, the raw table contains archived items, as well as items that aren't archived. So depending on your use case, it might be important to think about whether or not it makes most sense to use the raw table or the not raw table. In my example, I know that the notebook entries where these toxin kill curves, the actual results live, have not been reviewed. So it's important that I'm going to use the raw table because otherwise I won't be able to surface this information. If I click in to get a preview of the rows that live within this results table, I can see that there's a result ID as well as some other information here. But again, all the information that's user input lives over to the farthest right side of the table. So I think this is a pretty useful trick, is that if you're looking for which is the columns that are user input, they live to the farthest most right side. So I can see here in this experiment, there's fields for the result that are what toxin was used, what dose did you dose that toxin at, and then what was the final colony count on the Petri dish that was resulting from that dosage. And then here, these are strain entities that were being tested against. So a particular strain was being tested. So I'm going to copy this to my clipboard. And then what I'm going to do is write a query to join the this table with the strain data that was tested on. So the queries that I'm doing right now are fairly simple, but if you want to learn more about learning SQL, our customer experience team has put together a few videos that are sort of the introduction to SQL, as well as some other resources that we recommend for picking up SQL if you're just familiarizing yourself with it. My apologies, I'm not very good at multitasking here. So here what I'm doing is I'm going to join the actual result table that I copied and join it to the strain table. Great. So if I run that query, what I see is I've got my strain name as well as the toxin, the dose, and the colony count. I can see here that there's several toxins that were tested against several of the strains. So what I might want to do to clean up my data and make my dashboard look cleaner is to add a filter where I'm filtering by only one of these toxins at a time. So for this example, let's just say that I'm only interested in the kill curve for toxin A because that's the experiment that I ran and I want to just get the visualization of that. So what we'll do here is learn how to add a parameter. So in SQL, you can do a where statement. And so here I could do like such. And I can get only my toxin A results. But if I want to make this a parameter that researchers can filter the view by just simply using the parameter, what I can do is use a syntax to create this parameter. And the syntax in this case is to use these double squiggly brackets. And what this will do is if I run the query, it will now actually populate this at the top with a parameter that can then be filtered by anybody with read access to the query. So I can see here for right now, I've been given no rows. This is because this parameter up here has attained no value. So in order for me to now use to visualize data, I need to type in a value up here on this parameter. To configure the parameter, what I can do is click here. And configure in this sense means to specify what data type that parameter is. So by default, it's text, where you can just type in any text value. But in this case, it might be useful to use a dropdown so that it's very easy to filter the data. There's only a subset of kind of values that toxin can take on. So I have a dropdown here called toxin. And now if I go to use my parameter, I can see that toxin has attained a drop-down value. And again, I'm going to choose toxin A and then update the dashboard. What you'll see here is that now I've filtered the dashboard for toxin A, but it becomes very easy for me to, without changing the query, to quickly filter my data. The next thing that we're going to learn how to do is how to manipulate the visualizations of this data. So I can see here that this is all my data captured against toxin B, and I can see the different doses and the different colony counts. And I can generally see that as the dose increases, the colony count is decreasing. But for large data sets, this might not be immediately obvious, and you might want a quick visualization to get the big picture of what the data is trying to tell you. So in this case, what I'm going to do is toggle my output from a table output to one of the graphical visualizations. So in this case, what makes sense is a line chart that shows each strain and how its colony count decreases over an increasing dose of toxin B. But for other use cases, a scatter plot or a bar chart may be more appropriate. For example, the resource allocation and turnaround time in days dashboard that we saw earlier, where each sort of process attains one value of turnaround time. But for here, what we'll do is use a line chart. You'll see here that I'm given this update that the y-axis contains non-numerical values. This makes sense because a line chart needs to be sort of graphing some sort of numerical change over time. So what we'll do here is choose the y-axis to be the colony count. And then what we'll do is choose the x-axis to be that increasing dose of the toxin. So in this sense, what we would expect is that for an increasing dose, the colony count would drop. And you can see that here. But what you'll notice is that this is aggregating all of the data into one line chart. What it's not taking into account was that this data was captured against various strains, strains 1 through 4 in this case. So what I want to do is create a series which sort of separates my charts out into separate subgroups. So I want to say that I want to see the kill curve for each of the strains, not all of the strains at once. So what I'll do here is choose the name, which in this case is the name of the strains, and I'll choose that as my series. And here we have it. So here's the decreasing value of the number of colonies that are grown on plates as the dose of a toxin increases. Great. So if I go back now to the top level of my dashboard, I can see both of the blocks that I've created side by side. And I can get a view of what it would look like for a researcher who has read access to the dashboard to actually view it. So in the case of read access, the viewer would be able to view these visualizations as well as toggle the parameters, but the edit buttons here would be hidden to them. So they would not actually be able to go into a particular block and change the SQL query or change the X and Y axis visualizations. So in the case of write, you have access to all of this. But if you only have read access to a dashboard, you only have access to be able to toggle the views, which is still very valuable for somebody who has read access to be able to quickly come in and see some updated live dashboards of the data that's within Benchling. Last thing here is that you can always change the dashboard settings. So you can quickly change what project it's in so that the permissions can be set accordingly. Our recommendation currently is that your organization create a project called Benchling Insights so that you can sort of specify a custom set of people who have permissions to these dashboards off the bat. So that's sort of our best practice currently, is to create a new project called Benchling Insights, and that's where all your dashboards live. Last thing to note is that you can either duplicate or delete your dashboard. So please keep in mind that the delete may be changed to the more common archive sometime in the future. But for now, the dashboards are either duplicated or deleted. So again, if you have write access to a dashboard, be careful. And then lastly, I want to reiterate that this was done on a very small subset of the actual use cases that Benchling Insights can cover. And it was done with sample data that has no real world significance. And what makes me excited, and I know what makes Sanjay and the rest of the team excited about this, is that all of you in attendance today have real data that is of critical real world importance. And I think in times like this, it's important to make that data work for us, so that we can all as an industry come to new discoveries, new conclusions, and new therapeutics faster than ever before. So I'm really excited to see what everybody here is able to do with this tool, and supporting you all in the future.